Hello, I will show how to copy an existing circuit without having to draw the schematic. So this is only the PCB. We start by opening Inkscape. This is the Inkscape new project dialog where you go to other custom, where you go to custom and no layers to start an empty project. Then I like to select the layers tab here and import the image we're starting with. I have prepared this image, which is just a part of a circuit. I didn't want to include a whole circuit because it is probably copyrighted. So let's move it to the canvas, and then we can go to document properties and press this button to resize the canvas to the image. Now, what we can do if it's a nice image like this one, you can right click the image and select trace bitmap. This will try to automatically create polygons from the black and white sections of the image, and you can choose a threshold here to determine how black something has to be considered part of the polygon. Increasing the threshold here will include more and more of the image. So as you can see, if you zoom in on this image here, there are these feathered edges, and the threshold will determine whether they are part of the trace or not. So let's select, you can see it maybe a little bit here. If I reduce it, it includes less and the edge becomes rougher. So I do this by eye. Let's select something here, click apply, and now as you can see in the layers, it has created this path here. We can double click this path and see the polygons it has created. Quite a nice job. The only thing I don't like here is that the holes are selected as well. So let's start by cleaning this up. First, I'm going to delete these here because I don't want these to be part of the image of the trace. So let's go ahead, and for the holes, this is going to be a laborious process, but okay, so here something weird happened here. There's overlap. Let's see what it's done here. It has attached these points. So I'm selecting these by dragging and pressing delete. Now, how has it fixed this? Okay, that's nice. Then let's start by deleting the holes, and I will skip forward to when all of these have been deleted. Okay, so I've deleted some of the holes, not all of them, because it's a bit too much work. But I wanted to show something else. So let's say there is a piece of the trace that you're not happy with. You can just delete it or whatever. And then the way to move forward is to use the pen tool here, and then you can start tracing the shape yourself. If you just click, you will have non-continuous edges. If you click and drag, you can have a note it handles, and this one is continuous. The derivative is continuous. So let's go around and trace these. If you want, so let's say we create an edge here with continuous. I'm gonna go finish this first and then show you. Okay, so this trace is completed. What we can do now is go to select, double click to see the nodes, click this one, and then an option that you have is here to make it a corner node. Now you can move these handles independently, which is nice to create sharp corners. Or the main benefit actually is if you want different like this for very, very flexible shapes. This way you can trace any shape you want. Okay, now that we're finished, I'm gonna check by toggling this visibility option here, or of this. All right, so what we do now is select the paths that you want to export, go to File, Export. This will open a new tab here. I go with selection and select this. Choose to export it here as a plain SVG. Choose the path where you want to export it. trace, and now you have the exports. One thing that's important is if you have physical, if your board has to be physical quantity, so let's say the dimension for the distance between these holes should be a certain quantity, like let's for the sake of this exercise, let's say it has to be 5 millimeters. You can just select the measure tool here, hold Control and start dragging from here. This will measure the distance. As you can see now, this is 10.76 millimeters, which is larger than I said 5 millimeters. So let's zoom out, go select again, select everything, and now we can start resizing it by dragging these handles here. If you hold Control, then it will scale uniformly. So we have it has to be about half. Let's zoom in again by Control Scroll and measure again. So we're still at 6.5 millimeters. So again, zoom out, select everything, resize it a bit. Almost there. Okay, this is about correct. So this is the correct dimensions. It's important that you do this because otherwise the next step is you're going to waste a lot of time on the next step. So finally, I'm going to resize the canvas again. Voila. Okay, now select the plots. Go to Export, which is here. Selection, Export selected only. Choose a name. Export. Place the files that are there. Okay, now the Inkscape part is done. So let's go over to KiCad. In here, create a new project. The first thing we're gonna do, or the only thing we're gonna do, is open this PCB editor. And now we have to open the footprint editor because we're going to create a new footprint. All right, so this is the footprint editor. Now just save it as custom footprints. I'm going to create a new library for this project. Let's call it custom and call this one traces. Call it traces. All right. Now we have an empty footprint. These are the layers that we can work with. But what we're going to do is go to File, Import, Graphics. Okay, select the SVG we created earlier. There it is. With the correct scale. This is important. This is on which layer do you want the trace to be. So I take the front copper layer. You don't have to fix discontinuities, and then okay. And now we can place these traces. And as you can see, we now have a nice metal layer where we traced it. Now the only thing that's left is adding holes and vias maybe. So what we can do is go select the hole here, place it. There's snapping enabled, so it's a bit annoying. What you can do is use holding shift while placing the pad. Now there's a pad there. I'm going to edit the properties to make it a circular pad and roll where it's circular, and then we can just play with the diameter. I'm gonna just say 1 and this 2. No, it's 1 and 2. So this is the dimension of the whole pad, including the solder area, and then this is the diameter of just the hole that goes through the whole boards. I'm gonna select this, Control Copy, Control V, place it here, Control Copy, Control G, place it here. And what I can do now is like select these and choose to align them vertically. So now they're on the same line and I can move them together. And yeah, so that's how we do it. Continue with a couple more. And voila, let's say it's now finished. So I save this the custom footprints. Let's go back to the PCB. In here we can place footprints now, which we're gonna do our PCB. Voila. And here you can start placing other components if you want to, or creating vias. Like let's say we create a via here. Also, I'm also holding shift. Let's zoom in here and here, and then we can create a trace between them. On the front layer, let's go to the back layer like this. Voila. Now, what could be interesting as well here is if I try to draw a trace from this component to a via or this trace here, it's not possible. This is because they're part of different nets according to the softwares. What you can do is go here to nets, click this one. This opens the net inspector. Here you can add a net, and so let's call it middle. So it shows up here. Now we select these vias and trace, and we can go to properties, deselect this, and assign the net that we just created. And same goes for this through hole pad here. So we go to properties, no net selected here, so middle, and now we can connect these. Voila. So we only have the component here, but we also have to add the board's outline, which you can go to the edge cut layer here, select, let's say, a rectangle, and if you double click it, we can adjust the size here to square like this maybe. This is just for demonstrations. Then one more thing for the production files, if you want to send them to like JLCPCB, for example, what I find to be very helpful is if you go to the KiCad menu and go to the plugin and content manager here. Then you can go to repository, filter, and search for JLC. So this is a very useful plugin which you can install here. It's installed, as you can see. And then we go to tools, external plugins, fabrication toolkit, or as you can see, it's also here. Click it, generate. And now in our project folder, it has produced all these files, and this zip is one you can upload straight to JLCPCB. So if you go to instant quote and drag over the zip file, there it is. What's really nice is we can click on the Gerber viewer, look at our creation, and then also really useful, but this is also present in KiCad, but you can do one final check in the design for manufacturing check. So it's loading, click DFM check, it's doing the analysis. And these are the rules it has checked, so we can check, for example, trace width. It has 3 good results. We can check in the details. So they all pass. And it's just a useful final check. Okay, this was all. Thanks for watching.